are going to see example of determine the power and using Thellegens theorem. So we'll take some example. We'll take some example. For example, in this. So in this example, if I want to find the power absorbed of each element, power absorbed, I have to see the power absorbed in this part, power supply in this part, power supply. Even if you do not ask the power supply, but it's better to determine. So now let's see in this one, P1. Let's see, is it supplying or absorbing? How can we determine? The current was leaving in the positive. This current was leaving the positive terminal from here. So mean that since it's leaving the positive terminal, supply. I will have P1 from here equal, what's the voltage? 30 multiplied by the current. What is its current? Its current 10 ampere. It's going to be equal 300. But don't forget, since it is supply, you have to be minus 30 multiplied by 10 is going to be minus 300. This minus to show that it's going to supply. Now this element P2, is it absorbing or supplying? Let's see, the current is entering the positive. When current is entering the positive, means that it's absorbing. I will have P2 equal the voltage, which is 10 multiplied by what is the current 10 is going to be 100 watts. Now P3, this P3, the current is entering the positive, so means that it's absorbing. P3 equal, what's the voltage? I have 20 multiplied by the current is 14, which is going to be equal to 280 watts. Now let me see for P4, the current is entering the negative, or the current is leaving in the positive. This current will enter in the negative and keep living in the positive. When current is leaving the positive, means that supply. So I'll have P4 equal 8, don't forget the minus 8 multiplied by 4, minus 8 multiplied by 4, which is 32. So it's going to be minus 32 watt. Now let me see this one. Now this P5, is it absorbing or supplying? The current is leaving in the positive terminal. When current is leaving the positive terminal, means that it is supplying. I will have P5 equal the voltage. What's the voltage? The voltage, voltage is 12 volt multiplied by the current. What's the current? 0.40, 0.4 I. So this current is what? Is dependent source. Dependent source. Is dependent source. Is current dependent current source. Current dependent current, because they depended on currents again. So it's dependent source. We already see in the previous video that is current dependent source. So I have to determine with the value of this I. I will have 12 multiplied by 0.4 multiplied by I. What's the value of I? The value of I is what? You have to see in the circuit, whole circuit, to see the value of I. 10 is going to give equal, is going to be 48 watt. Now we already determine the power supply and the power absorbed. We should maintain the negative. Now we can check the Thellegens theorem. How would Thellegens theorem say? You have to verify. Even you do not ask, but we can check by our own. I have the power absorbed 100 plus 280 summation. I have summation of the power absorbed plus summation of the power supply. I have minus 300 minus 32 minus 48. I have to be equal 0. Let's check. 100 plus 200 is going to be 380 minus 300. I have minus 300 minus 32 minus 48 is going to be minus 380 equals 0. Mean that? Verify. We are going to also see another example. We'll do the same topic. Another example with the same topic. If you see the first one, what's a dependent source? We already seen the previous one. We said that dependent source are sources that dependent on currents or voltage. Now, different type. We have voltage dependent voltage source. Mean that in this we have the voltage dependent on voltage source. I know the symbol plus and minus, but now it's going to be dependent on another V0 or Vx because dependent on voltage source. I can also have voltage dependent on current source. How? Which is going to be in the same, but now it's going to be like E0 or Ex. Now it's dependent on current source. I can also have currents dependent voltage source. Now my current is going to depend on current source, on voltage source. I can have, even we can choose 3, you can choose just to for explanation on voltage source Vx. I can also have currents dependent on current source. And this one is going to be like this one, 2Ix, because it's dependent on current source. So for the second question, we'll see is we'll answer the second question. In this second question, what does he say? He told me to determine if the source is supplying or absorbing. I have to check this voltage, this one current is entering, this current entering in the source positive terminal, mean that since current is entering the positive terminal, mean that it's absorbing. Mean that is absorbing. So V is absorb. So I have to determine this one. Let's say this one is P1, so I will have power absorb here, like the previous example. The power absorb, this current is entering the positive, so it's going to be positive absorb. I will have P1 is going to be 3 multiplied by 10. 3 is the current, 10, 3 multiplied by 10, 30 watt. Now let's take this one. This current is entering the positive, so P2, if I make as P2 here, the voltage is 6 multiplied by the current 3 is going to be 18 watt. Let me check this one. If I make this one as P3, I will have the current is entering or leaving in the positive terminal. If current is leaving the positive terminal, mean that it's supply. For the supply here, power supply here, so I will have P3 equal minus 16 multiplied by 9. Minus 16 multiplied by 9, I will have missed. It's going to be minus 44. Now minus 44. Let me determine this one now. The current is entering or leaving. This current is the same current. The same current we pass here is entering the positive terminal. When current is entering the positive terminal, it should be absorbed. I will have P4 here. P4 is going to be equal 8, the voltage multiplied by 6 is going to give me 8 multiplied by 6, 48. Now Vs, we say it is absorbing because the current is entering. I will have PVS. Now by using the Thellegens theorem, say that summation of the power supply means that 30 plus 18 plus 48 plus PVS, because the supply, plus summation of the power absorbed minus 40. The graph was here. So I will have 30 plus 18 plus 48 plus PVS, which are the power supply, power absorbed, plus minus 144 equals 0 to determine PVS. If I sum in this one, 30 plus 18 plus 48 is going to give me 96 plus PVS equal, if I take this minus 44 to come here, it's going to be plus 144, mean that PVS is going to be equal 144 minus 96, 144 minus 96, 144 minus 96, which is equal 48 volt. So the power of the source is 48 volts. We see it is positive, so it verifies that it is absorb power. Now we see this example. He told us to find Phi0 and the power absorb. We'll use the same process. Power absorb. The power absorb. We have what? Let's check this one. The current is leaving. I have the power absorb here, and I have the power supply here. this current, this power, I say P1, the current is leaving in the positive terminal, meaning that it's supply. P1 equal the voltage minus 30, I put minus because supply, multiplied by the current 6 minus 180. Now I take this one, current is entered in the positive, meaning that it absorb, so P2, if I make this one as P2, so equal 6 multiplied by 12 is going to be equal 6 multiplied by 12 is going to be 72. So I will have 72 watt here. Now let me verify this one. For example, if this one is P3, I will have P3 equal what's the voltage? The voltage was the current, E3. What's the voltage? The voltage is V0. I will have P3 equal 3V0, since I don't have the value of V0. Now let me check this one. In this one I have what? Current is entered in the positive. Since current is entered in the positive, means that absorb. I will have P4. If I make this one as P4, I will have P4 equal 2 multiplied by 28. 2 multiplied by 28 is going to be 56. I will have 56 watt. Now let me check this one. I have 1. The current is entered in the positive, so I'll have P5 here equal 28, the voltage multiplied by 1 is going to be equal 28 watt. Now let me verify this one. The current is leaving the positive. When current is leaving the positive, it's supply. I'll have P6 here. If I make this one as P6 equal minus, since it's a supply, what's the voltage? The voltage I have 5E0 multiplied by the current 3. I will have minus, what's the value of E0? Since this one is dependent source, we already see there, I have to look at the circuit. What's the value of 0 is here, 2. I will have minus 5 multiplied by 2 multiplied by 3 is going to be equal minus 30 watts. Now I already found the power. I have to use the Thellegens theorem. Which is stated like summation of the power supply, which I have 72 plus 3V0 plus 56 plus 28 as the summation of the power supply, power absorbed, plus summation of the power absorbed, power supply, minus 80, 180 minus 30 have to be equal 0. Now if I calculate this one, I will have 72 plus 56 plus 28 is going to give me 156 here plus 3V0 equal, if I take this one, minus 180 minus 30 is going to be minus 210. This minus 210 is going to be in this side, is going to be equal 210 because it will change the sign. So 3V0 is going to be equal 210 minus, this value will come with this side, 156. So I will have 210 minus 156 equal 54. Mean that the value of V0 is going to be 54 divided by 3. 54 divided by this 3, it is going to be equal 18. V0 is going to be 18 volt, since it's voltage. So now mean that I already found the value of power absorbed and the power supply and the V0. So when you set this one, power supply, power absorbed, to find a parameter V0 or a current, you use the Thellegens theorem to determine that parameter. And to determine the Thellegens theorem, you use the power supply, even in the power absorbed. Even he did not tell you to find the power supply, but to use Thellegens, you have to find the power supply and the power absorbed for each element. Thank you for watching. Next, we'll